In this video, we'll learn about refraction. It is defined as bending of light when it moves from one medium to another, and that's too obliquely. So when light moves from one medium to another, say there are two mediums, air and water, and light moves from one to another, then instead of going straight, it bends. And this bending occurs when light moves obliquely, that means not perpendicularly. So that is shown in this diagram. So this is incident light. It is striking this boundary. It's a boundary between these boundary between two media, A and B. And light striking at the boundary, at the interface. This is normal. And instead of going straight, it's bending. It can bend either way, towards normal or away from normal, depending on certain thing, depending on the properties of the two media. So there are two rules. Rule number one, incident ray, the normal and the refracted ray lie in the same plane. And second rule, this is also called a Snell's law. It's also called a Snell's law. And the rule is this: refractive index of first medium, Na stands for refractive index. I'll tell you shortly. Refractive index of first medium, that is A, into sine of angle in medium A, and angle is measured from normal, is equal to refractive index of medium B into sine of theta B, where theta B is the angle made by the refracted ray, again from the normal. Refractive index of any medium is equal to C over speed of light in that medium. C stands for speed of light in vacuum, that is 3 into 10 to the power 8. And V is speed of light in that medium. So suppose in a medium, speed of light is half of that of in vacuum. So if in a medium speed of light is C by 2, then refractive index of that medium is this 2. If in a medium speed of light is C by 3, then refractive index of that medium is 3. So refractive index is this number by which the speed gets reduced. So more refractive index, as you can very easily now see, means less speed. And less speed implies denser medium. We call a medium denser in which the speed of light is less. So in denser medium, the speed of light is less and therefore refractive index is more. And from Snell's law, when n is more, then theta is again less. Theta being less means light is nearer to the normal. So in denser medium, light is nearer to the normal. So if you go and see again that figure, this figure, so if this is the situation, you can easily see that B is denser medium because angle in B is smaller than that in A. So angle being smaller in B, we can say that B is denser medium, its refractive index is more. We also have certain notations. NAB. This means Na over Nb. Na over Nb is written like this: Na and then B. B can be written here or here at this position. So Na over Nb, and if you put the value of Na, this is C over Va, Nb is C over Vb, then it will come out Vb over Va. So Na over Nb is called refractive index of medium A with respect to medium B. This is multiple refraction, when light refracts more than once while moving through different interfaces. Suppose there are N1, N2, N3 and again N1, these are the media and these are the interfaces, and interfaces are parallel to one another and light ray is moving like this. So if you go on applying Snell's law on every refraction point, suppose at this point, so it will be N1 sine theta 1 equal to N2 sine theta 2, and then this theta 2 will be equal to this theta 2 because these interfaces are parallel and therefore their normals will also be parallel. So these are two parallel lines, third line is cutting, these are alternate angles. So if you apply Snell's law at this point, so it will be N2 sine theta 2 equal to N3 sine theta 3. So that comes into continuation. And similarly go on applying Snell's law at every point. So you'll have this chain of equation. And from this equation you can very easily see N1 sine theta 1 is equal to N1 sine theta 1 dash. Light when comes from N1 to N1 again, then we can easily see that theta 1 dash is equal to theta 1. So in case of parallel refraction through many interfaces, when light comes into same medium again, it is parallel to itself. So this is one important property, that light moves parallel to itself when it comes again into the same medium.